Hello buddies, how are you? This is Sidhu, Senior Lecturer in Chemistry from Sri Chaitanya, Dr. B.S. Rao Nagar branch. Today we shall discuss about how an element is classified, especially into the block wise. We know that there are 4 types of block elements. First type is S block elements, next type is P block elements, and the next one is D block elements, and next one is F block elements. So suppose if I give an atomic number or anything like that, how do we know that which block it belongs to? We know by using electronic configuration. First let me define what is S block element, and then P block element, and so on, and then I will go for prediction of position of an element or block wise classification of an element in the periodic table. Let's see what is S block element. What is an S block element? So S block element is the element in which the differentiating electron is that the last electron while filling. The elements in which the differentiating electron is that the last filled electron enters into s orbital of valence shell. S orbital of valence shell, that is that ns orbital, is called S block element. Is called S block element. Is called S block element. And how do we know that an element is S block element? Generally, S block elements have 2 types of valence shell electronic configuration. That is the first group elements. What is the valence electronic configuration? NS1. And what are those elements? Excluding hydrogen. Hydrogen is S block, but generally we don't put hydrogen in first group or in 17th group also, because there is a controversy that we know. The position of hydrogen is still uncertain in the periodic table. Now NS1 means what are the elements? Lithium, excluding hydrogen I am writing, and then we are going to get sodium, and then potassium, and then rubidium, and then cesium, and then francium. Now the second group is the electronic configuration NS2. What are those elements? That is beryllium, magnesium, calcium, and then strontium, and then barium, and then radium. So these are the S block elements. And the next one is the P block elements. The P block elements. What is the definition? Let's go for that. What are P block elements? P block elements means here these are the elements in which the differentiating electron, again I am telling it is the last electron while filling, the differentiating electron is filled in p orbital of valence shell. P orbital of valence shell. What is that? NP shell. Is that we call it as NP shell or NP orbital. NP orbital. Valence shell is N, that is orbital is P. NP orbital. That is called a P block elements. We know that P block elements are actually in 6 groups. What are those groups? First one is which group? That is 13th group, and the next one is 14th group, the next one is 15th group, next one is 16th and 17th, and then 18th group. These are the different groups. What is the first element? What is the first element in this? That is boron. And the next one is carbon. Next one is, here we have got nitrogen, and then oxygen, and then fluorine, and then we will get neon. The next one is here aluminium, and then here we will get silicon, and here we will get phosphorus, and here we will get sulfur, and here we will get chlorine, and here we will get argon. The next one is gallium, and here we will get germanium, and here we will get arsenic, here we will get selenium, here we will get bromine, and here we will get krypton. And here the element, that is indium, and then this is tin, tannum, and then here we will get antimony, and here we will get tellurium, and here we will get iodine, and then here we will get xenon, and then here we will get indium thallium, and then here we will get tin, lead after tin, and then we will get bismuth, and then we will get polonium, and then we will get astatine, and then here we will get radon. We will get radon. The last series is very important. This is with atomic number 113 neonium, atomic number 114 flerovium, atomic number 115 named after Moscovium, livermorium, and tensine, and then adenosine. These last elements are recently, the examiner has a lot of interest in the last elements, because nobody generally focus on that. Therefore, be careful. Before the NEET exam also, you need to go through them once, the atomic number and matching with the element. So, these are the p block elements. What is their general electronic configuration? So, here the general electronic configuration for 13th group is NS2 NP1, 14th group is NS2 NP2, and this is NS2 NP3, and then this is NS2 NP4, and this is NS2 NP5, and this is NS2 NP6. So, these are the p block elements. These are the p block elements. Now, the next block is d block elements. So, what is the definition of d block element? There is a slight difference compared to the s block and p block. In s block and p block, the differentiating electron, the last electron enters to valence shell, but in d block, the differentiating electron or the last electron enters into the penultimate shell, that is also called n-1 shell. Let us go for the definition of d block elements. D block elements. So, here this is an element in which the differentiating electron enters into d orbital of n-1 shell, that is also called penultimate shell. This is also called penultimate shell. Is that n-1 d orbital. n-1 d orbital. Such elements are called d block elements. What is the general electronic configuration of these elements? General electronic configuration. General electronic configuration of these elements is, that is, first like this we will get n-1 d 1 to 10, ns 1 to 2, 0 to 2 also we can write, except there is some palladium, there is an exceptional configuration for that palladium. Then we can generally write 1 to 2, or some books they write it as 0 to 2, do not worry about that. Palladium has an exceptional configuration, that is D0, D10 and S0 configuration. Now, what are the D block elements and where is the position? Actually, the D block started from 3D series, but that is in 4th period. In fourth period we will get the series. In fourth period we got the 3D series. In fourth period we got the 3D series. The 3D series is from scandium, atomic number 21, to zinc, atomic number 30. And then in fifth period we got the 4D series, and then they are from yttrium 39 to cadmium 48, 39 to 48. And then sixth period they are actually the 5D series. This is from lanthanum, actually here it is 57, and then here we have the F block elements, therefore atomic number goes to for mercury up to 80. And then seventh period if we go for that is 6D series, that is from actinium 89 to copernicium with atomic number 112, like that we are going to get. So these are the elements in the D block series. Then let us go for F block elements. F block elements, not all elements I am writing. The main point is it is not that memorizing every element, it is about memorizing the position of each element in the periodic table. We will go for that one, the F block elements. Let us go for that. F block elements. F block elements. What is the definition? We know in P block elements the differentiating electron, or in S block elements the differentiating electron enters to valence shell. But here in D block we just learn the differentiating electron enters to penultimate shell or n-1 shell. Now in F block the differentiating electron enters to pre-penultimate shell or anti-penultimate shell or n-2 shell in the F orbital. So here the elements in which the differentiating electron enters into F orbital of anti-penultimate shell, that is n-2 shell. Is that n-2 shell are called F block elements, Clear? Now here they are present in the sixth period. F block first series present in the sixth period. There is 4F series elements. They are also called lanthanides. Another name of them, lanthanides. They are from atomic number cerium 58 to lutetium 71, 14 elements. And then in seventh period 5F series elements. They are also called actinoids, and they are from thorium to lawrencium 90 to 103. So these are the F block elements. Now if you see the periodic table, what is the position of these block elements? Once we look into that, and then we will go for, if I give an atomic number, how to predict what block it belongs to, what is the group number, what is the period number. That is more important for us. Now do look at, this is the periodic table we have got from NCERT. What is the position of these block elements in the periodic table? If you see, we know the S block, they are in the extreme left side, What are the general properties of S block elements? We know they are most reactive elements. First group is called alkali metals with valency 1. Second group elements are called alkaline earth metals with valency 2. Mostly most of them are metals with good metallic character. They can easily lose the electron. Their ionization energies are less. They tarnish upon exposure to air. They are highly reactive. They are soft, and some of the metals also can cut with a knife. These are the general properties of S block, which are in extremely left side of the periodic table. If you go for extreme right side, we get the P block, the most versatile group, where we find metals, non-metals as well as metalloids in this group. So in this group we have the metalloids. If you see the periodic table, look at silicon, germanium, arsenic, antimony, tellurium, polonium, astatine. These are considered as the metalloids or semi-metals. And then the blue colored ones, you see aluminium, gallium, indium, tin, thallium, lead, pneumonium, fluoronium. They are actually the metals. And then this group also has non-metals, boron, carbon and so on. And this group is most versatile group, which has all type of physical states in the elements. For example, some of them are solids that we know, metals especially. Here there is a liquid element also. What is that? Bromine, Br2 liquid. And then the gaseous elements also there. See that nitrogen N2, oxygen O2 and O3, fluorine F2, a gaseous element. Chlorine is also a gaseous element. So this P block has a versatile elements. Now come to the next, the D block. They orient between S and P block. So first NS is filled, and then N-1D, and then NP is filled. So this is N-1, the scandium. These all are metals. They are also called transition metals, except zinc, cadmium, mercury, because there is a transition of metallic character to non-metallic character through these elements. That's why they are also called transition elements. If you see the modern definition in the transition elements, there should be at least one incomplete orbital, that is d orbital, in the either neutral state or any of the stable oxidation state. That's why we know that zinc, cadmium, mercury are not considered to be transition elements. Now where about F block elements? Since there is lack of space, the F block elements are put at the bottom of the periodic table. It is space constraint, that's all. That's why they put F block elements at the bottom of the periodic table. They are from cerium to lutetium and thorium to lawrencium. So these are the elements that we got. We know D block elements all are almost metals, and they have metallic properties like ductility, malleability, sonorous property and so on. They are generally having high melting and boiling points compared to S block metals, except mercury. In fact, mercury is actually a liquid that we know. Mercury is a liquid due to weak metallic bond. F block elements also, if you see in that lanthanides and actinides, we call them. The elements which are after lanthanum are called lanthanides. The elements which are actinium are called actinoids. Lanthanides, if you see, some of them are artificial here, promethium like that, and remaining lanthanides are stable and they are available in the earth crust, and they are also mostly, they have metallic character. They are even more reactive than the transition metals. Now come to the actinoids. They are after actinium. Almost all of them are radioactive. In fact, if you see up to uranium, natural existence is there, but neptunium, plutonium and so on, americium, curium, berkelium, californium, einsteinium, fermium, mendeleum, nobelium and lawrencium, all are artificial or man-made elements. Not only these, if you see in P block, after the lawrencium, if you see the elements like rutherfordium, dubinium, seborgium, borium, hassium, metanerium, dermastadium, rentagenum, copernicium and neonium, these all are man-made elements. These all are man-made elements. You know one thing, when we were studying around 2000s, we don't have these many elements in the periodic table. When I was studying plus 2 level, so there were only 103 or 105 elements are there. Then the periodic table, in fact the last shell, we call it as incomplete shell at that moment. When we were studying in our text or literature, the last shell, what is that last period? What is that seventh period? We call it as incomplete period. But now the periodic table is completed. Now this becomes a complete period. Now in periodic table, all periods are complete. First period has 2 elements. What are them? Hydrogen and helium. Next period 8 elements, and the third period also 8 elements, and then fourth period 18, fifth period 18, sixth period 32, and also seventh period 32 elements. So this is the broad outline of the periodic table. Now let's go for how to predict the position of an element in the periodic table. Let's go for that. Prediction of position of an element in periodic table. For that, first we need to write the electronic configuration. First thing that you need to do is we need to write the electronic configuration. After writing electronic configuration, we will understand anything. Let's go for that. For example, I am giving an element, for example, with the atomic number, for example, they have given 53. For that, we need to write the electronic configuration. To write the electronic configuration, we need to know the basic idea about how to write. To get the 53 atomic number, we need to cross a noble gas. What is that? Krypton. That means 36 elements are already done. 36 elements or 36 electrons are already done. Now what are the remaining electrons we need to? Remaining electrons we need to fill. So 53 minus 36, we need to fill those electrons. 53 minus 36, we need to fill those electrons. Still we have 17 electrons remaining. Now after krypton, what are the orbitals we will get? That we need to know. We get actually 5s orbital, that I am writing as 5s2. After 5s, which has to be filled, 4d, 10, 5s2, 4d, 10. Out of 17 electrons, 12 I have filled, and then remaining 5 electrons I need to fill in 5p, that is 5p, 5. We have got what is this block by using the electronic configuration, where the last electron I have filled in p orbital. Therefore, what is this block? P block element. This is a p block element, that we are clear. And what is the period number? If you see, what is the valence shell? What is the valence shell? Fifth shell. The fifth shell, the last shell is fifth shell. Therefore, what is the period number? It is the fifth period element. Fifth period element. Now, it is a p block and fifth period. In p block, if the electronic configuration is S2 and P5, S2 and P5, that means what is this group number? 17. You can check that at the beginning in the slides I have given. So, what is the group number? The group number is 17. In fact, group number is 17th. In fact, by looking at the element also, some people are able to tell what is this element. What is this element? Iodine. Iodine belongs to halogens. What is the group number? 17th group. What is the period number? 5th period. What is the block? P block. Like that, there must be an approach to identify the position of an element in the periodic table if atomic number is given. Let's go for another number. What is that? For example, I am taking a number, for example, 78. I am writing it like this. Shall we go for that? How to write the electronic configuration of it? First of all, it is xenon we need to cross. That means 54 electrons. Xenon means we need to cross the 54. The milestone 54. Now what are the remaining electrons? 78, 54. 78 minus 54. We need to add how many electrons? 24 electrons after xenon. After xenon, what are the orbitals we have? 6s we need to fill, 6s2, and then 4f we need to fill, 4f14, and then what is remaining we have? Please do look at remaining we have, please check out there. So we have I think 6s2, 4f14, and then 5d. So can I write 5d? So this is already 16 electrons are there, remaining 8 electrons we need to write, 5d 8. By looking at, we can say that it is a d block element. However, there is an exception. Few exceptions you need to know. This is a special case. What is the special case? What is this atomic number? You need to know that also. Platinum. Platinum has an exceptional configuration. Here, one electron goes to d orbital. Then what is the electronic configuration of this? 6s1. 6s1. And what is this? 54. Now tell me, what is the period? What is the block? Just now we have learnt. It enters the d block. Okay, the last electron enters the d block. Therefore, it is a d block element. And then what is the period? If you go for sixth period, because n value maximum you have to see sixth period. And what is the group number for D block? Group number for D block, if you want, just add the s electrons and d electrons, you will get the group number. So add the s electrons and d electrons, you will get the group number. What is the group number? 10. What is the group number of this? 10. Like that we will get. So to calculate the group number of D block, just add the s electrons and d electrons, you will get the group number. Period number, block number and group number we have got. And also you have to know this element is platinum and it has an exceptional configuration. Let's go for next one. That is, for example, I am telling 80 or 103, okay, or something like that we can, okay, 87 I am writing. Let's go for all type of 87 means what is this? We need to cross radon. 86. After radon, what are the orbitals we have? 7s1. By looking at, we can tell what is this one? 7th period element. What is the period number? 7th period. What is the block? S block. Period number, S block. And what is the group? By looking at, we can say one thing. S block has only two groups. If there is S1, first group, S2 means second group. What is the group number? First group. This is an alkali metal. Actually, we can say it is actually francium. Let's go for one more. For example, I am writing for this 63. What is the group number? Let's go for that. Suppose 63 means I need to cross again xenon. 54 electrons already done. 63 minus 54 means we need to fill 9 more electrons. So after xenon, we have, what are the orbitals? We have 6s2 and 4f7. That means where the last electron is filled? F block. So what is the period number? What is the period number? That is F block, sorry, 6th period. What is the group number? What is the block number? Sorry. What is the block number? The block number is, actually, how do we know it? That is F block. Just now we have learnt, because the electron is filled, last electron is filled in F block. And what is the group number? There is one important point that you need to know. All F block elements, they put in one group. What is that group? Third group. Whether it is 4F block or 5F block, all lanthanides or actinides are put in only one group. What is that group? Third group. Very, very, very important one. All lanthanides and actinides are put in third group. That you keep in mind. So this is the prediction of position of an element in the periodic table. So based on this, I have just introduced what are different blocks and their general properties of the elements in the particular block. That's all for today. Thank you very much.